Hello and welcome to a new episode of wearing green shirts in front of a green screen. No, it's Advent of Code day 4. We have 2 new puzzles to solve, and today I got help. And it's not a human, unfortunately. It's GitHub Codepilot. So what is the Codepilot? It can autocomplete code, but other than your IDE that might autocomplete a function name, a parameter, this one will autocomplete whole blocks of code. And yeah, let's see if this is going to be helpful today. So let's start with just reading the text of day 4. You are almost 1.5 kilometers, almost a mile below the surface of the ocean, already so deep that you can see any sunlight. You can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of the submarine. Maybe it wants to play bingo? So, I really like the stories. This is the first year I do Advent of Code. I wasn't prepared for those stories. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen numbers marked on all boards on which it appears. Numbers may not appear on all boards, and if all numbers in any row or any column of a board are marked, that board wins. Increase the text a bit. Diagonals don't count. That is good to know. The submarine has a bingo subsystem to help passengers. Currently, you and the giant squid pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. For example, the numbers, and those are the boards. Okay. After the first 5 numbers are drawn, is here in the example, there are no winners, but the boards are marked as follows. Okay, there's some numbers marked, yeah. More numbers are drawn, and so on, and finally 24 is drawn. At this point, the third board wins. Yeah, there's a row here, because it has at least one complete row or column of marked numbers. In this case, the entire top row is marked blah blah blah. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. Okay, we need to sum the unmarked ones, okay. And in this case, the sum is 188. Then multiply that sum by the number that was just called. Okay, the last one was 24. 188 times 24. To guarantee victory against the giant squid, figure out which board will win first. What will your final score be if you choose that board? Alright. Okay. I think I've never played bingo myself, but I definitely know it from a lot of TV shows where people play bingo. Let's look at the input. Okay. This is a little bit more interesting than before, because we have 2 different types. We need to load the numbers, and then we need to load the boards, which are now split over multiple lines. Okay, let's save this. And then let's switch to IntelliJ. And let's create a new package. Day 4. And create a day 4 Kotlin file. Start with the main function again. By the way, I was wondering recently, maybe I should have written those as tests so that we can run them on. Oh wow, it's already autocompleting. Actually, let's try fun. Advent of Code, day 4, part 1. What does it autocomplete? Oh, it just wants to call part 1. That is boring. That would have been nice. Okay, let's run part 1. Let's move this up. I haven't really cared about formatting, but at least let's Well, that's interesting. It wants to read the list of passwords. That is weird. Maybe that was exercise from another year. Anyhow, let's get our input file. Let's move it to the root. And then we rename it like we did all the other ones. Day 4. Okay, so this time the interesting part will be how do we actually read this data and how do we want to represent it in code. So this is just a list of numbers. And we will probably create some class board. And inside the board we need to represent this data. So there are multiple options how we could do it, and we might want to choose the best one to solve this puzzle. So one obvious choice is, let's say, it's an array with 2 dimensions, like this is the first row, second row. We can put this in a 2-dimensional array. The first thing to figure out would be what is the value we store. We could store the number, but this has a disadvantage that we also need to somehow remember which are marked. We can either do something like a field. Let's just try to well, it's proposing to autocomplete it with completely unrelated stuff, but let's say a field could be a number and it could be a marked bool. This is one option. Every field in this board, and a board is just board stop autocompleting. And a board could be a dimensional array of those. Wow, it's almost annoying to have this inside comments. Can we somehow, oh yeah, escape makes it go away. Okay. There's another thing we could do. And so the winning, we can win by having a row marked or a column marked. The fact that it's a 2D structure doesn't really matter to the game, so we could just have, no, call it rows, call it whatever, but we could have arrays, or think of some data structure that keeps the rows, and we could do the same thing with the columns, essentially reformatting the data. And then keep them around like this. Okay, this looks longer now because I put a comma between them. Because we do not care if it's a row or column. We could just try to normalize this data into a structure that makes more sense to us. And then we just have a list of those. I think I like that idea. We still need to read this in though. And also the reading, we could decide, do we want to be fancy and read a dynamic board size, like those are all 5 by 5. We could just read as many as we get. Or do we to just write a hard-coded algorithm to read 5 by 5 grids, which should be enough here, right? Let's see. Let's start to write some code and then we will see. So read data. What's the data type we want to return? Maybe we want to return a pair. because we need a list of numbers and then a list of boards. Let's create a data class board here. We still need to fill with something. And then we say, what do we say? Let's just grab the code from here. Can still go by line, I think. Read lines. Day 4. And then we can immediately read the first line, I think. What does take actually do? Does it return a new list? Because we could take one away. Returns a list containing the first elements. No, let's just do while numbers equals with 0. And then we split it by comma, I think, right? Oh, that's the wrong file. Split it by comma, yeah. And then I think I just saw it. Yeah. Oh, go away. Yeah, Copilot proposes to map it to an int, which I completely forgot about, but yeah, that's exactly what we want to do. That was kind of helpful-ish. Now we want to read the boards. And oh wow. It drops one. Oh, that's cool, because we already read one. That is interesting. And it splits by... Okay, that is weird. I like this part, but I don't think we will need it because we will create a helper for the read board. And then we pass in the data. And then, yeah, it's a list of strings right now. We return a board. And now we just need to essentially write a loop that starts. Maybe skip this line and start here. Read the board. Read. And we end with an empty line too. So we could always just take 5. Let's try this. 4 E in values seeds. There's a way to do steps, right? Step 5. But we need to start at a different one. Well, start index, the indice plus 2. Go over this list. Actually, it's a 6 steps because we could just skip over this 2. Tell board to read from our values at the following position. And then we say read at... Now we need to remember those boards. Let's create a mutable list. And then we return a pair, as we said, of the numbers and the boards. That is actually correct by the Copilot. and we start at the start index. Oh, that does not work because the start index is now not a list, but we can use 2. Was it 2 boards? Oh, not board size, value size -1 though, and then step 6 does not work. let's for e until, oh wow, it is actually auto-completing it what I wanted to write. For e in start index until value size it doesn't understand the until. Why? Let's look this up quickly. Kotlin for loop until. When I saw it, I thought, yeah, that's exactly how to do it. Down to step 2. This should work. This is written for e in, and then what's 3 dots? No, 2 dots. Why is this not? What am I missing? This is valid Kotlin. Oh wow, that's interesting. And if I write this, okay, this does only work with actual numbers. Is this true? That would be weird. That cannot be right? Why wouldn't you want to do this with actual variables and not fixed values? Am I missing something? What am I missing? Codepilot! Help me! Like the way it writes it, it's exactly for e and start until value size. And it doesn't seem to be an import problem. Until. Oh, I'm stupid. This is a list, it's not the actual index. Start index is just 2. So it would be 2 until value size. And then can we still do steps? Steps 6. So this can go away. This can go away. And I think for now we will just do, let's just copy the list into it just to see if it's working so far. So part 1, yeah, perfect. Numbers and boards, read data. And then read board, we will let's just take a sublist for now. I just want to see how it works. And then read board, create a board with sublist from this position +5. So everything is hard coded to 5x5 mods right now. So far, so good. Except if in part 2 that will be a problem, but let's see. And now let's just print this, I guess. For bot inbots. Print the data. And let's take a look. We're executing day 3. That doesn't make any sense. Let's execute day 4. Okay. We got a ton of bots. We have some numbers. Let's quickly check this makes sense. So it starts at 8311 and stops at 2586. Awesome. So we have exactly this data in here now. And the comma is because we are printing a list of strings. So awesome. Now we need to split. And sometimes you have those double things here, but I don't think it matters much. Now we need to build a bot. Oh, that's day 3 again. So now we need to decide how we want to represent our data. As a 2x2 array or as a list of winning conditions with 5 numbers each. In any case, we kind of to build this 2D structure because we need to read it once to turn it into the nicer format, I think. So maybe we will end up actually creating the 2D structure. How would this look like? We have another class number, and it can be data class again, I guess, and it's the number. So that would be exactly what we had before. So the number is immutable and can be marked. Correct prediction. And then we need to always check all rows, all columns, which is maybe actually fine. So the data is now, how do I even define a 2-dimensional array in Kotlin? I'm not sure I've ever done this. Array, it's an array of a number, yeah. And then, oh, that is awesome. That's how we can initialize it. But we actually don't do that, I think. This is an interesting way to initialize it, but now it's initialized with number 0. We could make it nullable. Doesn't matter. It actually does not need to be initialized, I guess. What is it complaining about? recommended to override equals in hash code. Doesn't do this for data classes. That's interesting. To be honest, I actually do not really care about this, so maybe just turn it into a class so that it doesn't annoy us. So now we need to read the board. Well, board data is this, and then we loop over split. Row data in board data equals row data. That was correct already. I always press keys and the prediction or suggestion from GitHub Codepilot goes away. Okay, now we have a row of data. Oh, interesting. This is actually writing code that it's a number and sets the number. Huh. That is not what I was going for here, but maybe just steal this. We create an array with is 0 a valid number, by the way? Oh, we can't search for 0, obviously. But there's no 0 in the top line. So that is actually maybe not too bad to initialize it with 0. And then we create a board here. Yeah, thank you, Copilot. Then we return the board. Yeah, thank you. And now we set the data. Board data index of row. Oh, we actually need, it's a good point. Board data each indexed. And then it is, yeah, row and line. And then the data is this. A line split. Okay, let's, now we know the rows, so we write board data a row, and then for each indexed column number dot number. Oh yeah, that is weird. Maybe call this a value. Board data row, and then for each indexed column number no, we want to loop over the data. See, now that I see it, let's actually stop. Turn it back into a data class because that will be print later. So we have a line. We loop over the line and we for each index again. This is essentially our column value, and then the actual value, and then we say board data row column here is a number. Yeah, what I want to write. What is it complaining about? Name shadowed. Yeah, that is the row data. Okay, the naming is super awful. Okay, so this should give us a board like this. Let's see what we get. Narrow. Okay, number format for input string empty. that is likely here. So we need to make sure if there's an empty string in here, which might happen here, that we ignore the empty strings. Let's see if this is the case. Oops. If we create a Scratch file, which is, by the way, super awesome in IntelliJ, it's a file where you can just try stuff without adding it to your repo and running it. You have kind of a live editor which gets evaluated immediately. So if we do this, well, data, and then we do data split by empty string, we get empty strings in here. So we want to filter everything that is not empty. Then we get just the numbers. Okay, let's do this. Filter, it is empty. Oh, and then it's mapping it to int immediately here. Let's do this too, and then we do not need to do it here. Like that idea. Let's go. Okay, numbers. Okay, it looks like arrays are pretty awful when it comes to printing them. So let's do what the thing wanted us to do and write our own toString function, which is not exactly what I wanted to do. Data join string. And then row join string number. It takes the rows, joins them by... I don't understand this, but it looks good. It looks like it actually creates a grid separated by line break and then separate by nothing, which is weird. That's something we might want to change. And then it either prints an X or the number, and it ignores the size. Sometimes we need 2 characters, sometimes 1, so we could fix this, but let's not do it right now. Let's just run it. And it's still complaining because what do we actually print? The board data. We can now print the board instead. Okay, we get a bunch of things without anything between it. So here we want this. Yeah. Now it's still not formatted nicely, but we do not care about this part. Let's just compare if this is actually the board we want. 83 to 45, 26 to 86, 83 to 26. That looks correct. Awesome. So that all of that was just reading the data. Let's now actually process the data. That's what we need to do here. Let's comment out the debugging code. Let's just remove it. Let's go back to the exercise. What do we want to do? We take the first number, mark all the boards, see do we have a winning board. If not, we continue. And we continue until we have a winning board. Then we return, or then we need the winning board and we need the last number. So find board. And this returns a pair of the number and the board. And then we pass in our list of numbers, list int, and then we return our list of boards, Now we ask Copilot to just do everything, which will be interesting. Come on. Oh, nice. Winning board equals board, the first board where all numbers and value in numbers and not marked. The winning number is the winning board. Okay, I have no clue what it does, and it doesn't look like what I wanted to do. So what we need to do is to loop over the list of numbers for number and numbers. This part is okay. Get away with that. Then we loop over the boards and do what did I write here? For board in boards. And then we ask the board to mark this number. And then we could already check if the board is a winning board and return it. If board is winning, is winner, then return pair of number and board. Now to essentially only implement those methods and do something if we don't find a winning board, which should not happen, but we need to somehow handle this case. Let's just, yeah, like Copilot says, throw an exception, no winning board found. So quick review of Codepilot. It is actually sometimes helpful. And like this exception, I would have written exactly this, and it was just pressing tab. It is interestingly quite correct at times. Like this loop that I struggled so much with, the idea it had was correct. Let's see if it actually can write a mark function, because that almost seems obvious what should happen to a human. So let's try this. We have a num, or let's say a value, because that is the same name. So it goes through each row, and for each row it looks at the number, and if it's the value, then it's marked. That is correct, I think. Just take it. This winner. It goes through all rows if all numbers are. No, that is unfortunately not correct. So what we will do now is go through all rows, see if all are, then we go through all columns. And maybe we write two functions. Is column this row it's a winner if it's, or it's a column winner. I mean, there are fancy ways to do it. If we would have transformed this from this two-dimensional thing into a list of winning conditions, then would be much easier to check now, because we just go through this list. And overall it have been interesting too. If we would have created this winning conditions, we could even have, let's say, a list they are all lists of 5 numbers, and we could remove the numbers we marked instead of using the boolean. This list gets shorter until it's empty, and then it's super easy to check the condition because we can use collection operators to find empty lists in it, and then we are done pretty fast. So, but now let's do the kind of the hard way, going through the array. So maybe do it hard-coded. The default case is we return false, and then we go row by row. So the y-axis first, for y in 0 until 5, that was correct. Until 5, all the other thing it is doing, I don't know. Marked, unmarked. Oh, it it is actually doing what we want. It goes through the columns, the rows, and then counts marked and unmarked, and then returns true if 5 are marked. Returns, yeah, that is interesting, but it's completely useless to count both. I was going for a boolean, but then when I saw this, like, counting is interesting too. Let's try this. What I wanted to do first, I go through if winner turn false. The interesting thing, Copilot turns you from writing code into just reviewing code, which is kind of weird because now I'm reviewing Codepilot instead of thinking about what I wanted to write. So let's maybe just write what I wanted to write. So I go through all of them, and if data epsilon x, if it's not marked, oh, we need to actually start with true, and if it's not marked, we set to false. And after running through all, if we have a winner, we return true. And now the column winner is almost the same, except that we go the opposite. Oh wait, did it adapt to what we just wrote? Winner's true, like here, and then we go over y. Oh, yeah, nice. It essentially reproduced the code we just... Otherwise it's false. If there's one thing I don't trust, then it's the implementation of those methods. We could write, of course, a test to make sure this is actually doing what it should do. But you know what? We will just run it and see. Back to this. Where are we? Here. So we have numbers and boards, and we want number and the board by calling find winning board, as it says, and then we say, hey, the winning number is this, and the winning board is this, and then we still need to calculate the solution, but let's see if we even find one. Okay, awesome. We find a winning board. Actually, do a line break here. So we've correctly identified a column here. That is great. I think that is great. The winning number is 90. So how do we calculate the result? Start by finding sum of all unmarked numbers on that board. In this case, the sum is 188. Okay. And then multiply it by the number. Let's do this. Let's create a helper on our board again. Some unmarked numbers. And then it flattens the data, which is fine. It filters, takes everything that is not marked and then sums it up. Wow. So that is awesome by Codepilot. I always say Codepilot instead of Copilot. Like, why didn't they call it Codepilot? Anyhow, I probably wouldn't have written it that compact, but it looks awesome. Let's print this too. What sum of unmarked number sum. See, print this. 916. Is this possible? Likely. I won't check it. Line break, and the result is sum times the number. I'm kind of optimistic because we actually got a result. We to any of the cases where there is no. And printing the board, it looks like we have a valid result, but let's see. So it's 82,440. Multiply, yeah. Let's see. That's the right answer. Awesome. Part 2. Let's see. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is figure out which board will win last. Ooh, and choose that one. That way, no matter which boards it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called, and it's in the middle column. And its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148 for a final score of. Figure out which board will win last. Once it wins, what would the final score be? All right. So we can make use of all the code we wrote, I think. The code we wrote finds auto-completing stuff already. Finds this is distracting. In a list of boards, it finds the winning board. So we can just use this and essentially reduce the list by the winning board until there's only one board left. I think that should fairly well. There's just one thing. If we compare boards, something I'm a little bit concerned about is that it says you should overwrite equals. So I think since there's only one type of data, maybe we can override equals by just doing data is other data. Oh. If other is not a board, return false. Content equal. Okay. And what is it still? Hash code. Okay, I mean, I don't need it here, but we can do it. Return data. Content hash code. Interesting. I didn't even know this existed. Returns a hash code based on the contents of this array. Awesome. So let's go back to this. We need to read our boards again and our numbers. And now we create board candidates, which is just our list of boards, but it is now mutable. And then we say while board candidates size is bigger than 1, find the winning board and remove it from the list. Okay. And then yeah, we just have one board left, and then we take the numbers and then we print all this stuff again. Board found. Oh, do we need the number? We need the number. We will get to the number. Last number. We use it here. Let's print this to and number. Okay, so the idea is we get our boards, we create a mutable list of boards, and we loop over this board as long as we have more than one boards. At some point we have only one board left. We print the last number and then calculate the sum and then multiply it again, and then awesome. So the only thing left to do is find the winning board and remove it from the list, as we said. So yeah, auto-completing number, winning board. And we say the last number is the number, so we can remove. And oh, if we now do exactly what it proposes, to remove the winning board. No, that's fine, I think. Oh, we might be missing something. There might be boards that every board should win at some point. Okay. Let's run part 2 from the function. Last number was 63. Oh, this board is complicated. Where's actually the winning? Okay, the formatting is confusing. Let's copy this over. Did we find a winning board? Let's turn it to something that. Because if this is not a winning board, then we might have a problem. Oh. This, that is tricky. It's good that way she printed this. Because there's one thing now. This is the last board that is left over. And we found it. Last number 63, this one. Interestingly, is not marked. Let's ignore this for a second. It's the last board, but it has not won yet. So let's check again. It might be wise to try to let the giant squid win. Don't show. It's the last to win, which happens after 13, is eventually called. So we still need to continue the game. We found this one board, but now we still need to find the number with which it wins. So board and the number it wins by on winning board, list of board. Awesome. So now we need to replace the values here. And then this one needs to be our winning board, because we need all the unmarked numbers from the point it actually won. Why can't this not? What is winning? Shit, it's exactly the opposite. That happens when you use Codepilot. Okay, let's look at this again. This wins with 94, which is maybe better. Yeah, here's the winning column. That looks good. Here we won. Can I use this multi-cursor? Whoops. I can't find it. There's a way to have multiple cursors. Well, doesn't matter. The middle column is the winning column. 221 is left over. We could almost calculate it now. Looks plausible though. And the result is 20,770. Submit. That's the right answer. Awesome. So we completed day 4. Let me know in the comments how you solved the puzzle, if there are more fancy ways to solve it. And you can find my solution on GitHub, and the link is in the description. And I hope to see you tomorrow for day 5. Bye bye.